after we have done with the titration, we have the titre values. If you can check here, we have our HCl, which has concentration, it is 0.1, but for our sodium hydroxide, it is just indicated sodium hydroxide, it has no concentration. So it is from these titre values that we have obtained that we will now be able to calculate the concentration of sodium hydroxide. And for us to calculate the moles of sodium hydroxide, we first of all need to write the equation. And the equation that is the equation for the reaction that is taking place between HCl and sodium hydroxide is as indicated here. HCl plus sodium hydroxide, it will give you sodium chloride plus water. This is in aqueous state, liquid, and you must check if the equation is balanced. And from this you can see that, how do you check if it is balanced? You can check by each atom. You can check from the reactant side, we have 2 hydrogen atoms. On the product side, we have 2 hydrogen. The water are balanced. The other side, you have chloride ions, which is 1. In the product side, we have 1. You have sodium. So it is balanced. So from this, and remembering that the volume of sodium hydroxide used was 25 mils, and the average titre value, volume of HCl being to 19.00 mils, and its molarity for the acid being equal to 0.1, we can now calculate the moles of the sodium hydroxide by first of all starting with moles of acid used, which is equal to 19, the volume, that the titre volume, times its molarity, which is 0.1, divided by 1000. You will get 19.0 multiplied by 1000 multiplied by 0.1 divided by 1000. You get 0.0019 moles. This is the moles of HCl that was used, and we have said, since the ratio of HCl to sodium hydroxide being 1:1, so we can now calculate. We say moles of acid is equal to moles of sodium hydroxide. So moles of sodium hydroxide is equal to moles of HCl, which is equal to 0.0019 moles. But remember, the volume of sodium hydroxide that we used was 25. So, and we have gotten the moles to be this, then it means these moles are in 25. So you will come and say, and now we calculate the molarity of sodium hydroxide, which will be, you use this expression if the volume that we used, 25 mils of the sodium hydroxide, contain 0.0019 moles. And we know molarity is the number of moles in a liter. So we will now, if 25 mils of sodium hydroxide has these moles, then 1000 of the sodium hydroxide solution will contain how many moles? Then you will have 0.0019 multiplied by 1000 divided by 25. So you'll have the molarity of the acid being 0.076 molar, which is approximately 0.1 if you round off this. So you can see that it is kind of relating to this ratio of moles of acid to moles of sodium hydroxide being 1:1. So if you round off this, you will have 0.1, which is exactly the molarity of sodium hydroxide, the molarity of the standard that we use, which is HCl. And that marks the end of today's presentation.